This is the 2004 wedge and particle on wedge question. Separate diagrams. The forces involved for the wedge. If it wasn't smooth, there'd be something going on between it and the ground, but it is smooth, so we call this R1. There's a reaction between it and the particle, and its mass of 4g is coming down. The particle will have this same R going in this direction here, and it's going to have 3g coming down. The wedge with the angle of 45 degrees in here, it's going to move in this direction with an acceleration of a. So with R being the reaction here and creating a right angle triangle with R as the hypotenuse, the force is going to be R opposite by 45, which will be in here. R sine 45 is equal to its mass times acceleration. For the wedge or for the particle, or going in this direction by 45. So I'm going to have 3g coming down here by 45 in here. Just mark the angle. So opposite the R is going to be 3g adjacent cos 45, which is equal to 3g over root 2, and parallel to the plane 3g sine 45, which is also 3g over root 2. For my acceleration, we know it's going in this direction here, so if I create a right angle here, I've got my corresponding angle now to 45, and I create my one parallel and perpendicular to the plane. So here's my right angle, so A is here, so this is A cos 45 along the plane and perpendicular to the plane A sine 45, so both A over root 2. So my forces, so we'll start with this one here with the or 3g over root 2. You can say that 3g over root 2 minus r is equal to m times the acceleration, which is a over root 2, this one here, and in this direction here, parallel to the plane, we have 3g sine 45, nothing opposing it, that's equal to m times the acceleration. Well, it's coming down the hill in this direction with an acceleration of b. We'd have to take away what's going on in that direction, which is relative to a, which is the a cos 45, which is the a over root 2. So b minus a over root 2. So we can take our first equation, or by sine 45 equals 4a, is r over root 2 is equal to 4a. So r is equal to 4 root 2 times a. So this in here, we're going to get 3g over root 2 minus 4 root 2 times a is equal to 3a over root 2. So multiplying by root 2, we're going to get 3g minus 4 2 is 8. 8a is equal to 3a. So 11a is equal to 3g. So a is equal to 11. A is equal to 3g over 11. Yeah, 3g over 11. So now I need to get b. So using this equation here, 3g sine 45 is 3g over root 2. That's equal to 3 times b. So 3b minus 3 times a over root 2. So minus 3 over root 2 times a which is 3g over 11. So multiply by root 2 again, maybe. 3g is equal to 3b over root 2. I could see it divide by 3 as well. I'll do that at the next stage. So we're let me delete that. I'm going to multiply by root 2 and divide by 3. So multiply by root 2 over 3, everything. So the first one's going to become just g. That's going to be equal to root 2b minus, you imagine, a root 2 over 3 here. This one will cancel with one of the 3, so we're going to get minus 3g over 11. So g plus 3g over 11 is equal to root 2b. So that would be 14g over 11 is equal to root 2b. So just bring the root 2 underneath. So b is equal to 14g over 11 root 2. So second part of this question, let's find how far the wedge has traveled when the particle has moved a distance of 1 meter down the inclined wedge. So we need to know the time it takes to take the wedge, which has this acceleration of b down the plane. A is equal to 14g over 11 root 2. It starts from rest, and we need to know time here, so we can sub this in and find out how far the wedge moves. SUAT, S is equal to UT plus a half AT squared. So 1 is going to be equal to 0 times t plus 1 over 2 by 14g over 11 root 2. I think I'm just going to calculate this now in a minute, equals t squared. T squared works down to be 11 root 2 over 7g. Just let me check my maths there, which is better as 0.23. So we just sub this into, we have the acceleration for the other particle of 3g over 11. We have time of 0.23. It started from rest, u is equal to 0, and we know that the distance it wants to have traveled. So s is equal to ut plus a half at squared, so it's just a half by 3g over 11 by 0.23 to be squared. And typing this into a calculator gives an answer of 0.3 meter, rounded to one decimal, or 30 centimeters if that's what they were looking for. So TR, I hope you got to the end.